Hello everyone, welcome to the next question for NEET problem. Again, this question also belongs to electromagnetic waves. So the question is a capacitor made of two circular plates, so each of radius 12 centimeter and separated by the distance of 5 millimeter. So they taken a capacitor, that capacitor made up by two circular plates. So each of the plates having the radius of 12 centimeter and separated by the distance between two circular plates is 5 mm. So the capacitor being charged by an external source. They are using some external source for charging the capacitor. So the charging current is constant and equal to 0.1 ampere. So what they are asking, they are asking to calculate the capacitance and the rate of change of potential difference between the plates. So now we will go for the answer. So what are the data given in the question? They given the data of radius, distance. Okay, so the radius is, they are given in the radius is 12 centimeter. So it will be converted into meter, so that is 12 into 10 to the power of minus 2 meter. And then the plate separation, so the distance between two circular plates is d is equal to 5 mm. So again you convert it into meter, means that is a 5 into 10 to the power of minus 3 meter. So it is the circular plate, so the area of the circular plate, formula A is pi r squared. So you know the value of pi, we will substitute that pi value later in that capacitance formula. So pi into radius value is 12 into 10 to the power of minus 2 whole square into meter square. So these are the data they are given. So you know the formula for capacitance. So capacitance of the capacitor formula C is equal to epsilon naught A divided by D. It's a very simple formula. So epsilon naught is a permittivity in the free space. That value is 8.85 into 10 to the power of minus 12, and area pi, that is represented as 3.14, and the area A is equal to that is pi, that is 3.14 into r squared value, 12 into 10 to the power of minus 2 whole square, that is pi r squared. So divided by d. So d is represented as the distance between two circular plates, so that is 5 into 10 to the power of minus 3, right? So once you substitute this value, we will get a final value of 80.1 into 10 to the power of minus 12 Faraday. So it will be get the final result of 80.1 into PF. Okay, so 1 PF, that is equal to 10 to the power of minus 12 Faraday. That's why we are taking PF, that is belongs to 80.1 PF. So now the charge of the any instant of the capacitor plate. So charge is simple formula, that is Q is equal to C into V. Okay, so C is represented as the capacitance of capacitor and V is the potential difference. So here you know that value of I, that is I means current. So current is defined as the rate of flow of charge. So that is Q represented as a charge. So the rate of change of means that it will become dQ by dt. So d by dt, so Q value is CV. So you just substitute the value of Q into dQ by dt, so d by dt into CV. So you just separated the term C and V joined with the d by dt, so C into dV by dt. Thus the rate of change of potential difference between the plate is, you can find out the value, because I is equal to C into dV by dt. So dV by dt is the rate of change of potential difference, because V represented as a potential difference. So d by dt means the rate of change of potential difference. So that is dV by dt, that is equal to that C goes to opposite side, it will become, already have a left hand side as I. So C is a right hand side, it will goes to the opposite side, it will be I by C. You know the value of I, that is equal to 0.15. So already given in that question, that is 0.15 ampere. Just substitute the value of I divided by capacitance value. So 80.1 into 10 to the power of minus 12. So it will be get a final result of 1.875 into 10 to the power of 9 Vs minus 1 voltage second minus 1. That's a final answer. I hope you understand this question. Thank you so much.